Hi, welcome. This is an overview of experiment 5B, acid bases. This is a simulation, and I want to go over the simulation and how to complete the datasheet. Please remember to do the pre-lab posted in the assignment tab on Canvas. I'm going to share my screen and walk you through the data collection for experiment 5B. Uh, this is the screen, and by now I think you should be seeing the data sheet. I want to pull the simulation. I want to pull the simulation. This is the home page for the Canvas. You'll come to the modules, scroll all the way to experiment 5B. The second one here is the data sheet, and this is the simulation. This is the simulation. I'm just going to load this, and we will come back to this. I'm just going to load this, and we'll come back to this. What I want to do is, all right, what I want to do is go to the, I'm going to the module and download the instruction, which is pretty straightforward, all right? It is pretty straightforward for 5B. This is the document. It has the background information I want you to read. I know you have covered in the lecture. Acid and bases, you should be able to differentiate strong acid, strong bases, all right, and how to determine the pH, hydronium ion concentration, hydroxide ion concentration, all right. Remember, uh, the pH of a weak acid is not determined the same way as the pH of the strong acid. Even though we use the same equation, the difference lies in how to find the hydronium ion concentration. I don't want to go in details on how to find hydrogen ion or hydronium concentration in or for a weak acid using ice table. I'll leave that to experiment 5A. This experiment, this simulation is only based on strong acid, strong bases. Please read on the background, use any other resource material which addresses determination of the pH of strong acid and strong bases. So right here, you scroll down and you'll come to, all right, you'll come to the link. You may want to download this or you can use this. What I want to show you is what this stand for. This is, this knob here is the water inlet. If you want to add water to the container here, you will pull this. To drain the trap, you will pull this side here. This is to drain, and this is the solution selector. By using the drop-down menu here, you will select different solution based on the data sheet. Let's just show you the data sheet here, all right? Maybe you can just blow this up. If you look at the different types of solution here, you will use the solution selector here, drop down menu for saliva, for blood and stuff like that. You'll use this to drain, and to drain, you squeeze the red button here. This you'll have to drag into the container to determine the pH of that solution. This is the pH scale. It's going to change from solution to solution. So familiarize yourself with this diagram. This is the calibration of the container. Each subdivision represents 0.1, okay? It is 0.1. For example, here 0.1, 0.2, 0.3, 0.4, 0.5, R is 0.5 all the way to 1 liter. Let's read the direction here for part one. All right. What you'll do is start by selecting the water, press the red pattern, and dropper will fill to 1 liter slowly to make sure that you're familiar, you're comfortable, see how you can fill the container. All right. And you'll take the peek of that and see. So part two, part one here is part one is the hydrogen ion concentration for some common household items. So you'll start by adding point one. Let's see if we are talking about H2O, for example. I hope this one, let's see if I uh, click this, it will load the simulation. This is the simulation. And if I pull the, you see the water is filling, all right? So if I pull, it's gonna let the water fill all the way to one. You gotta be careful when you get to almost, you don't want to overfill, all right? So it's gotta be slowly all the way to 1 liter, all right? You may want to put, yeah, that is 1 liter. You're looking for that. So if I want to measure the pH, I'll just have to pull this into the solution, and that is the pH of H2O. If you want to train, you just open this and it will train, all right? It will train, it was neutral. You can remove this and select, let's say, I'm gonna select coffee, all right? Let me just select that coffee. The direction here, all right? The direction here talks about the way on adding. How many do you need to add, all right? For the solution, you'll have to add point 0.1. You'll add point 0.1 of the solution here. You add point 0.1 and measure the pH of that solution. So this is, I selected what, coffee. So I'm gonna train until I have point 0.1, all right? Should be point 0.1. Yeah, point 0.1. And then I'll measure the pH of, maybe you need the cross. That is the pH P4. If you look at the data sheet, this is before you add 0.9. Here is where you will put table for the solution before dilution. So if it was coffee, I'll put the pH here, all right? So what was my pH here? Let's see, pH was 5. So what I'll do is I'm gonna put 5. Please record with the correct units. All right, 5.0. Oh, no, this is, I'm gonna clear. This is the volume added, which is 0. What? 0.1 liter. I think all of them will be 0.1, and the pH here is what? pH is 5 point 0 0. All right. pH is 5.00. Suppose I want to find hydronium concentration, hydrogen concentration from the equation hydrogen ion concentration H3 O positive. It's hard to write with the mouse. I'm just gonna put that equals to 10 raised to what? Negative pH what? pH value. And please read the background on the expressing the pH with the correct number of significant figures, the hydrogen ion concentration with the correct number of significant figures. It is slightly different, all right? It is slightly different from the conventional way of expressing your final answer with the correct number. You know, like this is two, this is gonna be two. It is different wherever you are handling with, wherever you are dealing with strong acids, strong bases, or generally acid and bases, finding the pH. So if you know the pH, all right, you know, you can find the hydrogen or hydronium ion concentration. Once you determine the value for hydrogen or hydronium ion concentration, you know from the background the product of what? Product of hydrogen ion concentration, all right, and what? Hydrogen ion concentration and hydroxide is equals to 1 times 10 raised to negative 14. You know this from the background 1.00 times 10 raised to what? 10 raised to negative 14 times 10 raised to negative 14. So if you know the other one, you can find the other one. Please show your work where applicable. What I want you to do is only do this, what you are given on the data sheet, all right? So here is the, after the dilution, you are adding 0. What? You'll have to add 0.9. I should have done that. So let me just exit here, or I could clear this. Let me just clear this and then exit right here. And we will see what happened when you do it, when you dilute now with what? With 0.9 ml or zero point 0.9 liters of H2O. So we're gonna train that. You gotta start over again. If you overshoot beyond 1 liter, you'll have to start over again. So it's gonna be slowly, all right? Initially, you can increase the rate. Initially, you can increase the rate. So make sure that you always have what? You have exactly 1 liter after the dilution. You can remove the probe, called the probe, pH probe from the solution. Oh, I don't want to overshoot. This is tricky. Yeah, there we go. So it got to be 0.9. This is the what? This is the pH, all right? This is the pH after the dilution. So what you do is come on over here and I'll go to what? I'll go to the coffee. So I was dealing with coffee. I added what? I added point zero 9 liters, and the pH increase to 0.98. I believe this was the pH, all right? That was the pH of what? After the dilution, 5.98. That's what you will add. And then, of course, find the hydronium concentration, all right? You'll find the hydrogen or hydronium ion concentration using the same equation used before, and do what? Determine the hydroxide ion concentration. Thereafter, you will answer the follow-up questions. There are follow-up questions below the data sheet, and you are all set. Please include your workout. You may add additional scratch papers to show your calculation. Otherwise, you will lose points if you don't include calculation. That's it. Thank you. If you have any question, please do email me or see me during the lab time next time you show up on campus. Thank you. I'm gonna stop sharing my screen now. See you next time.